So, good morning to our climate farm demo and climate smart advisor meeting on measuring soil carbon with the Eddy Covariance Technique. We would shortly like to introduce the two projects, but just very roughly, and give an introduction why soil carbon is relevant for being measured. But then the main part will be the presentation of Andrea Pitaccio from the University of Padova in Italy on measuring with the Eddy Covariance Technique. We will also have some time for questions. So if you have some questions already, feel free to share them in the chat. I also wrote in the chat that we will use for some of the presentations the Slido questionnaires or questions. So if you want, you can already log in. I will also share the link again in the chat. So this event is co-organized with Climate Farm Demo and Climate Smart Advisors. Climate Farm Demo is one of the European projects with the implementation and demonstration of climate smart solutions to go for the carbon neutral pathway of European agriculture. It's organized with a bunch of partners and organizations that are joining this project. In total, more than 20% of the farms that are involved are organic farms, and also some of them are on specialized arable crops, animal husbandry, and horticulture crops. So it's quite a good mix of different farms that are participating. In total, it's more than 1,500 pilot farms. And on these, a lot of events are taking place. And this is also the reason why we come together also with this, because in Climate Farm Demo, we also have theme events where we are currently at to really come into the discussion with the farm advisors and the farmers and the different stakeholders of a climate neutral pathway. We have this different thematic areas. One of them is the soil health and biodiversity, where FiBL is responsible for managing this for the Climate Farm Demo project. And you'll find a bunch of information about the different events that are happening on the website. That's basically it about the Climate Farm Demo project. If there are any questions, feel also free to reach out to me. And I would like to hand over to Marco for shortly presenting the Climate Smart Advisor project.
Good morning, everybody. I introduce briefly the Climate Smart Advisors project, the next one. The next slide, please. Thank you. It develops during these years in 27 nations. Each nation has a national coordinator, and the focus of the project are 260 community of practices that will be activated during these years, and this community of practices will involve more than 1,000 advisors all over Europe and on several different thematic areas. The next slide, please. Today we are speaking about the soil and health and the biodiversity thematic area. The next one. And the role of thematic leader is to coordinate and connect the community of practices to support knowledge exchange among all advisors. And during the meeting of this single community of practices, the advisors will share the best practices and create new knowledge for advantage of professional practice. So it can be very interesting for professional activities to be involved in the community of practices. The next one. And the next one as well. What is the soil health? I believe that soil is the heart of the life on Earth. So it means Times ago, we think to soil just as a process of physical disintegration and chemical alteration with influences a little bit from living organisms. But now we have to understand, and where it must be clear that the soil is a living organism. It's the most important resource for man, for humanities, with water and air. And without biodiversity, there is no soil. It's not possible to have a soil without biodiversity. The next one, a soil without biodiversity is dead. So we have to increase knowledge and awareness to rethink the technical approach to the production. And we must believe in the possibility to be sustainable, sharing knowledge with farmers and obtain sustainability and efficiency of farms. The next one. So during this project, we will organize seminars and scientific activities, the COPS activities, the interaction with the sister project Climate Farm Demo, and to increase knowledge and awareness among advisors. Please, the next one. And during these seminars and scientific activities, the arguments will be to deepen knowledge about soil's fundamental characteristics and functions, how to measure soil health, soil biodiversity, and soil functionality, to understand which are our impacts on soil and which can be our activities, which can be the strategies to improve quality of soil. So I finished, and now I leave the stage to the next speaker.
Thank you, Marco. Yeah, I thought it would be good at the beginning to just have a very short introduction about the role of soil carbon and why measuring it is relevant when we want to go to a climate neutral pathway. Just have to change again a little bit my sorry, 1 second. Yeah, so when we look at the climate, we will see that that the role of carbon, and in particular agriculture, is compared to the other sectors in the European Union and the greenhouse gas emissions about 10% of the total emissions. So agriculture has an important role when mitigating climate emissions, but it's still compared to other sectors such as the energy and transportation sector, yeah, not such a big role. And when we look at the reported emissions from the agriculture sector, we will find that the majority of emissions derive from CH4 methane emissions. So these are the emissions from animal husbandry, and also the N2O emissions from the soils, so cultivating agriculture soils. Of course, also then from the manure management. And sorry, something is wrong with my presentation mode. And about 5% are other greenhouse gas sources, and this is mainly the CO2 emissions that derive from fossil fuel consumption, or yeah, the emissions also, the carbon emissions. However, I really would like to emphasize that when we talk about climate change mitigation, the emissions that I just showed are just the direct emissions that are reported by the European Union and the respective national country levels. However, there are also a lot of indirect emissions that derive from agriculture production, and these are often not included. But if we include them also in the relevance for the agriculture sector, then we come up with a much bigger percentage of emissions that are caused by agriculture. And globally, there are some studies which refer to agriculture and food system emissions between 21 to 37% of the total world emissions. And there we can see that the relevance then is even much higher. If we look at the carbon, I would like to find it interesting what you would say, how much of the global carbon is actually stored in the soils, like how much percentage. And for this, I would like to ask you to go to Slido and answer if you think it's this 99.94% or if it's 0.05 or 0.0037% of the global carbon that is stored in the soils. We'll just wait here for a second. So there's a tough race between two very different numbers. So the one is the 99% or the 0.05%. And yeah, spoiler alert. If we look at the numbers, it's actually very interesting because in total we have about 75 million of gigaton of carbon in the Earth on our planet, on which 99% or more than 99% is bound in the limestones. That was a reaction. And only 0.05% is actually bound in the oceans, so also still very relevant, and 0.0037 are bound in the soils. So this is basically then the soil humus and yeah, the soil humus mainly. So you see, like what is interesting is that the communication is often very different, but still, I would say, even when it's such a small percentage, it's still relevant for the climate because it's still a lot of gigatons that are stored in the carbon, stored in the soil. And for me, it's also important to really highlight that that if we store carbon into the soil, this has a lot of co-benefits besides climate change mitigation. So the soil is really, as Marco also said, it's so important for our agriculture production because it increases the aggregate stability, reduces soil erosion, and all of these other benefits that come with an increased soil carbon. And therefore, it's one of the things where I would say we have a win-win situation if we really increase soil carbon in our agriculture management practices. So if we really try to increase the soil carbon, because it has a benefit for the mitigation of climate change, but also for a lot of other aspects of farming. And if we look at how many factors are actually influencing the soil organic carbon, we will see that this is quite a complex topic. So it's not such an easy system where we do something A and then the result is B, more increased soil organic carbon, but the soil organic carbon is really influenced by so many different factors that it's a hard thing to measure. And for measuring it, there are a lot of different techniques available, and one of them we will look into more detail during our presentation from Andrea. But it just to show all of these methods, so this is just the small selection of methods. All of these methods have different advantages and disadvantages. So I think it's very important for the farmers and also for the farm advisors to really choose the techniques that are good for their farm and for their situation they're dealing with. If we look at the different challenges of the measuring with soil organic carbon, we will find that one of the main challenges is that we will have, we are having different soil potentials of increasing carbon sequestration. There's a nice article about it, why carbon certificates can be questioned as a suitable tool for climate mitigation. Because one of the challenges is that depending on the soil, you will have different organic stocks already, and increasing the organic stocks then will be, for some of the soils, quite easy. For others, it will be really challenging. And it will also depend if you really want to increase the top layer labile carbon pool, or if you want to really increase the overall stable pool, and which is also going then to deeper layers. In our DOC trial, which is a long-term system comparison of organic, conventional, and biodynamic systems, we find that the carbon losses are lowest in the biodynamic treatment and highest in the conventional system. This is a very long-term trial, so it's more than 40 years, 45 years, really showing that the carbon sequestration takes some time in the different systems, and is highly dependent also on what kind of input you give into the farming system. So, for example, the biodynamic system is also the one where we use a lot of animal manure to really enhance the soil. If we look at the other problems with the carbon sequestration, we have to look at additionality. So this is also relevant for organic farms, that we don't compensate something which is already done at many organic farms. And then also the permanence. So this is what I talked, is the soil carbon really something which is permanently stabilized over a long time, or is it already turning again into CO2 emissions with one tillage management? We have to look at potential new emissions that derive from practices that enhance soil carbon sequestration, and also the leakage effects. So there are a lot of things we need to consider, and this is also the reason why currently in most of the tools that are used also for the projects now, for the European projects, soil carbon sequestration is often left out a little bit from the balance of the climate balance calculations, and this has good reasons. But anyway, I think when we consider the soil organic carbon, it's always important to remember ourselves again and again and again that we really need the system transformation towards sustainable agriculture systems, and their soil organic carbon can be providing benefits for the climate, but also for the other areas. And I think for this, the Eddy Covariance is a good technique because it combines different aspects of soil organic carbon. And therefore I would really like to hand over now to Andrea, but if you have questions, just put them in the chat already. Thank you. So Andrea.
Yes, thank you, Lynn, and good morning, everybody. Can you hear me?
Yes.
So thank you, Lynn, and thank you, Marco, for the invitation. I will try to give you a very fast introduction to the technique, to the Eddy Covariance technique, which is a very interesting and powerful technique to understand vegetation atmosphere interaction, including soil fluxes. Briefly, I am professor at the University of Padova. Oh, I cannot, sorry. I teach viticulture, so I am involved in agronomy, but my background is in plant ecophysiology and in micrometeorology. So I try to apply this technique to agricultural systems, which was not very common in the past 20 years. Briefly, vegetation is involved in the exchange of very big quantities of mass and energy. If we think about water, all of us know that easily vegetation can exchange some kilograms of water per square meter per day. That is the evapotranspiration flux. But it is much more difficult to understand and to measure how much carbon is absorbed or exchanged by vegetation. So some kilos of water and few grams of carbon per square meter per day. This is a long story. I don't want to waste your time, but the understanding of carbon exchanges started in the 18th century. And one guy is especially famous for that, which is Jean Senebier. He understood that carbon dioxide is relevant to vegetation, and it started trying to make some estimates. So water is somehow easy to measure, not completely easy, but in principle we can weigh the soil and the vegetation to continuously measure how much water is lost to the atmosphere. With carbon is very much more difficult. So we can think about enclosing plants in cuvettes and make flux measurements of portions of plants, of leaves or even stems or whatever. But this has been used since the 60s to understand plant metabolism, but it is not really easy to do, and especially is not very representative of the plant behavior. We can even imagine to enclose plants in bigger closed environments like that, but the perturbation that is imposed to the plants is so strong that the results are not really representative and convincing. Especially when we deal with agricultural systems, we want to understand, yes, how much photosynthesis is going on, but we should not forget about respiration, and we should not forget about soil. So we have to consider several fluxes going into the soil, into the system, and out from the system. So what we would really want to know is the so-called net ecosystem exchange. So the net flux of CO2 and water between the vegetation, including soil, and the atmosphere. And at that point, the relevant question is also the possibility to have a continuous monitoring, not just a sample every some days or some hours. We really need to have long-term continuous measurements of soil and vegetation exchanges. At this point, the big family of micrometeorological methods come into play. And this is a very nice and very powerful bunch of techniques which rely on the basic understanding of exchanges between natural surfaces, soil, vegetation, and the lower atmosphere. I mean that exchanges of CO2 and water and energy between the system and the atmosphere obviously change the chemical composition of the atmosphere around the plants, and so measuring the flux in the atmosphere without touching, without enclosing the vegetation may yield a measurement of vegetation fluxes. So this is the very basic principle. For those of you which are interested in this kind of measurement, I still recommend quite an old paper by Dennis Baldocchi, Bruce Hicks, and Tilde Myers, which appeared in Ecology in 1988. This is a very nice paper introducing the micrometeorological techniques with the constraint of these techniques and with the advantages. So I really advise you to go to this paper. Basically, the big advantages of micrometeorological technique, and eddy covariance is one of these, is that these measurements do not disturb the canopy. So we can start long-term years, many years of measurements, continuous measurement without affecting the environment around the plant. So we are measuring really the normal average behavior of plants. And these techniques, the sampling of these techniques refer to a very big area. So we do not sample just few leaves or few plants, but few hectares of vegetation. So the spatial sampling is very appropriate to understand basic ecological processes. The difficulty is that around the canopy, the air, the atmosphere is in a very complicated continuous movement, which is turbulence. I mean, everything, every compound, water, CO2, heat, is moved by eddies, by turbulence around plants. And this makes things a bit complicated, but today very, very possible to be measured. So what we should understand is that around our canopy, a kind of layer develops, which is very much affected by the exchanges between vegetation and the air. So wind going on the canopy, flowing on the canopy, is somehow reduced in velocity close to the canopy. And so we have a vertical gradient of wind speed. So that means that a layer develops above the vegetation, where the atmosphere is very much affected by the vegetation itself. And at the end, what it is important is that turbulence develop above the canopy. So in this boundary layer, the fluxes are more or less constant, and we can measure fluxes without touching the vegetation or enclosing the vegetation in any box or cuvette. So somehow the air flowing on the vegetation is affected by the exchanges between vegetation and the atmosphere. So gradually, after some distance from the edge of the plot, the atmosphere, the air above the canopy becomes conditioned by the fluxes. So this is the very basic principle of micrometeorological measurements. I do not want to enter too much in theory and details, but one thing that I really would like to convey is that this is very physically based. I mean, these techniques are quite sound and reliable because they are based on fluidodynamics concept. So somehow we enclose the canopy in a kind of theoretical box, and we measure fluxes in and out this box. So it is not a measure, I mean, it is not a method to estimate fluxes, but these are methods to measure fluxes. So this is a direct measurement of fluxes, and this is important. Some mathematics is required. I mean, I don't want to scare you with this slide. So the technique is not easy, but today is very much diffused and adopted in most of the ecological research. So we we cannot find easy solution to a complicated problem. So eddy covariance is not really easy, but it is possible, and I strongly advise you to understand the basic principle. Time is short, but again, here I was somehow showing you that how the basic physics of plant environment interaction gradually simplifies after few hypothetical assumptions, simplify to a very small expression. So the flux between vegetation and the atmosphere reduces to the covariance between the vertical wind speed and the concentration of CO2 or water or whatever you like to measure. So the complicated picture that I show in the first slide reduces to a very simple expression which related flux of anything to the covariance of wind speed or vertical component of the wind speed and the concentration. So this is the very basic assumption of the eddy covariance technique. So at the end, what we do is just measuring the upward and downward movement of wind, which is carrying the constituent that you are interested into. So if you measure at the same time CO2 concentration and vertical wind speed at a very high frequency, many times per second, 10, 20 times per second, we can make a budget, a balance between upward and downward movement of air, carrying our CO2 upward or downward. So the problem is that wind speed and CO2 concentration, they change very fast every few milliseconds. So we have to sample concentration and wind speed at a very high speed, 20 to 10, 20 times per second at least. But at the end, we have the flux. We measure the flux, the vertical flux of CO2 and water or whatever. Instruments are somehow still a bit exotic, so we have to use a static anemometer, which is a sonic anemometer, and an anemometer which measure wind speed in the 3 dimensions. So the vertical wind speed is also crucial. We cannot rely on mechanical anemometer. We rely on sonic anemometer. So anemometers which yield the wind speed from the measurement of time which sounds used to go to a very short path. And we have to measure the CO2 concentration at the same time with spatial analyzers. This is my station, one of my stations. It is running since roughly 10 years. So it is one of the longest, or maybe the longest series of CO2 measurement in vineyards. And this station is belonging to a European network dedicated to the greenhouse gases. This is the integrated carbon observation system. It is a network mostly deployed on natural vegetation and natural ecosystem. There are few stations on agricultural land, but some are included in the network. So it is a very important initiative, and I guess that the contact between these initiatives should be, improved, like today we are trying to do. Results of our measurement have been published in some articles, and I can share these papers. But basically, we have been measuring the fluxes of CO2 and water and heat since 10 years. So every few minutes, every 30 minutes typically, we can measure how much CO2 is entering the system or going out from the system. During daytime, the flux is, mostly downward. The CO2 is being absorbed by the vegetation, while during nighttime, CO2 is released from respiration processes. Obviously, during winter time, with the little radiation, fluxes are smaller, and with the higher radiation in summertime, fluxes are relevant. But it is important to understand that the total carbon flux during a day is in the range of a few hundreds or a couple of grams per square meter per day, so not much. And if you integrate this flux throughout the season, you end up with a number which is in the range of a few hundreds of grams per square meter of carbon. So I mean that if you think about a paper sheet is somehow like 70 grams per square meter of paper. It is like that we lay one or a couple of paper sheets on the soil every year. So this is somehow the quantity of carbon which a standard vegetation may absorb in a year. So not much. And this is the main reason why a direct measurement of carbon concentration in the soil, it is so difficult. And so, so I would say, yes, difficult to prove the carbon sequestration. So micrometeorological techniques are really sensitive. They have the proper sensitivity to understand the carbon fluxes, and much better than direct measurement in the soil. So what we can do is to understand how seasons develop, how much water is released, how much carbon is absorbed in the season, day after day, hour after hour, year after year. So this is really relevant information about canopy functioning, water consumption, and carbon sequestration. And we have these budgets for many years now. We can compare seasons concerning respect to evapotranspiration and carbon budgets, and come to pictures like these, where the years are very nicely described. For global radiation, so energy input, air temperature, humidity, and finally evapotranspiration, and very relevant, the net ecosystem exchange. So if we stay on this picture for a few minutes, we can see that these are 6 years, 2015 to 2020, and each picture represents a daily course, and the color is relative to carbon exchange. So on top you have January, so the season is going like that, it's going downward. You can see how seasons are different, and you can integrate these fluxes to have a yearly absorption. You may be familiar with the initiative like this one. So the very optimistic 4 per million initiative launched in the Paris COP a few years ago. But yes, everybody is speaking about carbon and soil carbon and carbon sequestration, but the problem is still to understand how much is the carbon exchange. So in this respect, Eddy Covariance is really a very important, a very relevant, a very useful tool to understand fluxes. This is the fundamental result of eddy covariance measurements. In green, you have the daily absorption of the vineyard. So you can see that every day during summertime, we can catch something like 1 to 2.5 grams of carbon per square meter per day. And in black, you have the integrated flux during this time span. So you can see that at the end, in these years, the square meter of vineyard caught something like half a kilo of carbon per square meter, which is really something. So after half a kilo is not much, but the important thing is that the harvest, the grapes that you harvest and bring to the cellar are not, using all this carbon. A lot of carbon stays in the field, since the harvest is more or less just 30% of the total carbon absorbed by the vegetation. So what we found is that the carbon which is left in the field and obviously mostly in the soil is somehow compensating all the carbon, the CO2, which is released by the technical inputs. That meaning that the vineyard or a perennial crop like a vineyard can really be carbon neutral. So this is a very important result of this research, and we could come to this result only using the eddy covariance, because it would have been really difficult to prove this absorption with other methods. So this is including fluxes into and out from the soil. This is including the growth of woody parts of the perennial. This is including every flux in the system. So year after year, we come to these kind of figures and budgets, and we have been able to introduce this method in the official documents concerning the carbon budgeting of grapevine in particular, and we have been able to prove that the so-called biogenic fluxes must or should be considered to understand properly and very generally the carbon budget of agriculture and especially of perennials. So our final conclusions are that standard methods are like life cycle assessment are not completely adequate for understanding the carbon footprint of crops or agriculture, but instead including the biogenic flows, the biogenic fluxes may really may give a far better picture of carbon budget of these crops, eventually coming to the conclusion that, to the scientific conclusion that this crop can really be carbon neutral. So this is somehow the end, and I hope I have been able to give you a very fast glance of Eddy Covariance technique. It is not easy, but it is very powerful. And today, I would encourage all of you to, consider this measurement for a better understanding of carbon budget in agriculture. Thank you.
Thank you so much, Andrea, for your inspirational presentation, and it's a good sign because we have several questions in the chat. So that's always a good sign that people are following and wanting to know more. Maybe some of them also ask if we can share the paper details or if something could be repeated. So we will share the recordings and the presentations with you. So this is something where you could always look back as well. One of the question was, or two questions were, I think, a little bit related. So could you maybe elaborate a little bit on what this means for the farm advisors in particular? So does your result implicate that we would need a different kind of agricultural practices, or how the Eddy Covariance Technique could be used for farm advisors in their daily work? And the second question was then also, like, if you could maybe elaborate a little bit on what would be a reasonable sampling size to come up to these results. What would be maybe related costs with this? Yeah, I think these are the first two I would like to start with.
So thanks to all of you that put this question on the floor. I mean, unfortunately, we have very few stations on agricultural crops. We have many stations, many hundreds of stations on forest system, on natural system, very few on agricultural crops. This is, I mean, somehow historical, and I cannot enter easily this question, but we have few stations on agricultural crop, and so few information on agricultural fluxes. And this is very much a difficult position for agriculture, because for a long time agriculture has been considered a carbon source and not a sink. So it is a long story that would deserve, I mean, a bigger effort in measuring agricultural surfaces. Yes, under the grams per square meter means 1 ton per hectare. That you're right. I mean, and this is something. I mean, just to compare a forest, a good forest. I mean, the flux, the carbon yield of a good forest in a year can be 400 or 700 or 800, but not much more. I mean, a forest in the northern Sweden can absorb 300 grams, so not 10 times a vineyard in the Mediterranean environment. So this is something important and relevant. So we are not too far away from I mean, a forest flux. The drawback of Eddy covariance is that we need large and flat extension of homogeneous vegetation. So for the technique to work, we need an homogeneous site, you know, some hectares, 5 hectares, 10 hectares, this is optimal. We cannot do Eddy covariance on small plots. So this is also the reason why it is difficult to compare different treatments with Eddy covariance. So, for instance, organic versus conventional. We would need 5 hectares of organic, close to 5 hectares of conventional to have a proper comparison. But, you know, in time, these activities are coming more and more realistical, so not easy, but possible. ICOS data are public. I mean, ICOS is a European strategic research infrastructure, and all the data are publicly available on the portal. So they are completely shared. The cost the cost of Eddy Covariance is not, Eddy Covariance is not cheap. A rough estimate could be 50,000 euro, 60, 70,000 euro. It depends on it also depends on the crop, because the higher you go, the more complicated is the structure to deploy the instrument. Instrument have to be deployed above the vegetation or twice the height of the vegetation. So it is easy on sugar beet. It is more difficult on an apple orchard. So the cost of the structure is changing. But yes, a rough estimate is 50 or 60,000 per station today. There are instruments which combine the gas analysis and the wind speed measurements, and they cost roughly 30,000 euros today. The thing is that when you deploy an Eddy Covariance system, you also would like to have additional ancillary measurements of basic meteorological variables like radiation or rainfall or everything. So what you would really like to set up is a complete station, not just the Eddy Covariance. So this is increasing the cost of the whole structure. So Eddy is just 40,000 or 50,000. You have to add additional instruments.
Yeah, and I just saw in the chat that this was also referring more to the soil sampling methods and how many samples are needed to make a proper soil sampling with the methods that I presented shortly in the table. There, I would say this depends on the purpose of the soil sampling. So if you really want to have a soil sampling which is very specific and detailed, you actually need quite many soil samples, because at least at FiBL we see that even the carbon content can differ within like a 10-meter range quite a lot. Or if you would like to just have a rough estimate of how much carbon your field has, so this really depends on what kind of detail level you would like to achieve with your soil samples. And if we are talking about policy context, then I think there's really the question how to find a balance for the carbon crediting issues. So how to have enough samples that it's representative, but still not too much, so that the farmers don't have to sample every 2 steps in the field, so to say. Yeah, Marco, I see you're raising your hand.
Yes, just to add something about the usefulness of these techniques for advisors. Of course, this information must be used at the political level for policymaker to make them aware of what is happening in agriculture. But for advisor, I believe that to have this kind of information can increase our awareness about the importance of agricultural method to reduce the impact of agriculture. So it's not necessary to measure everywhere what we are doing with, and it's not possible to measure everywhere using this technique because it's very difficult and expensive, as Professor Pitaco said. But we must know that we must remember that we can do something for environment and for climate using the appropriate techniques, agronomical techniques. I have to add that the entire flux of CO2 from the field is due also to the grass coverage. So it's not just vineyard, and so it's necessary to have the sequestration is absolutely necessary to have grasses in the vineyards. Of course, this is not possible everywhere. For example, in southern France or southern Italy, it's more difficult. But when you think to reduce the impact of agriculture, you must, for example, use grassing coverage during autumn, winter, and first spring to increase carbon sequestration using grasses, and this can help to increase soil carbon content, and can reduce, for example, erosion. Erosion is one of the biggest worsening for soil, and so at least during autumn, winter, and the early spring, we must have grass coverage in the fields to have several useful additional utilities for our environment and for our soil quality.
Mm-hmm.
So that's why it's important that an advisor knows and always remember this information.
Yeah. Thank you, Marco. So I would like to use the last minutes to ask you, some of you, to see what kind of seminars would also be relevant for your future work in both projects. And maybe meanwhile, Andrea, you could elaborate a little bit on the last question about the positive balance of within the vineyards. So one question was why there was a positive balance in the first 2.5 years. And I just read the comments so that you know. Please, could you comment on why you think the carbon balance is positive for these vineyards? Is photosynthesis exceeding respiration because of the imbalance in the atmosphere due to higher CO2 emissions? If CO2 emissions reduce, would the vineyard return to equilibrium, for example, in photosynthesis flux equals respiration flux?
Thank you, Lynn. I mean, this last question is interesting. Yes, you have absorption. You have the photosynthesis usually exceeding respiration, and this is the basic reason why vegetation grows and you have an harvest. I mean, photosynthesis always exceeds respiration, and so you have the growth. And yes, if we have 420 ppm of CO2, vegetation is just happy respect to 280, but I don't think that reducing emissions would deplete vineyard budget. I mean, in any case, even if we could go back to 280, vineyard would grow, and photosynthesis would, would exceed respiration. So we should not think that vegetation is in balance. Vegetation is usually growing, and that means that photosynthesis is large with respect to respiration. Another question concerned the sheet of paper analogy. I mean, this is a very important analogy because a sheet of paper is somehow like 70 grams per square meter. And this is the range of, a couple of sheets of paper is the range of the absorption that we measured in our vineyard. So 140, 200, something like that per year. That is a nice view of the total quantity of carbon that you can expect to fix in your soil. So not much, a couple of sheets of paper. So this is the reason why finding this carbon in the soil is so difficult, because you should think about 2 sheets of paper in the first, 80 or 100 centimeters of soil. So it is very difficult to find the carbon with direct analysis. So, but yes, it is a nice view to show, to convince people how little carbon is going into the system. But again,
Yeah. Thank you so much. Yeah, with these words, I would really like to thank you again for being here and presenting your interesting research, and for Marco to providing the link and support with the organization of this event. Yeah, we will use your inputs and questions for designing further soil events for both projects. And yeah, I would like to express my gratitude to everybody for being here and for participating, and wish you still a good rest of the day and the knowledge exchange week with many interesting presentations. Thank you so much.
Thank you, everybody, and keep in touch for the next events. Thank you, Lynn. Thank you, Andrea.
Thank you, Marco, Lynn, and Andrea. Have a nice
Thank
day.
you to you.
Thank you. Bye-bye.
Bye. Thank you.
Bye-bye.